Today I'm gonna explain the differences between EKS node group and Fargate profile. So first, I will show the EC2 node group, right? So assume that you are a developer here, and then you run kubectl, right? Uh, to deploy some pods, via kubectl, and kubectl command send to control plane. So I draw control plane, where is the control plane live? It live in an AWS managed VPC. So AWS managed VPC control plane. And the first important component is API server. API server. The second important component is the scheduler. So you send your command to an access endpoint. Kubectl. Deploy some pod, right? Okay. And then API servers work with schedulers to launch the pods you want. In case of node group, what happens? So let me draw the data plane. I draw it a bit slowly. Okay. So in this case, the data plane live in your account, your VPC. So your own VPC data plane. And you create a node group, right? There are several options. The first one is you can create AWS managed node group. AWS managed node group. Or you can manage itself, by yourself, or self-manage. Okay, so I assume that I use AWS managed node group, and inside it there are some EC2. So I draw the first EC2. This is EC2. Inside EC2, the first component is the kubelet. So kubelet will communicate with the API server, right? It watch for the API servers. It watch for pod spec, right? And then it will launch the pods you want. For example, pod 1 and another pod 2. Okay. Similar, we have another EC2. Okay. And those EC2s are managed by AWS node group. So let me draw or mark it by an box. So the dashed line So this dashed line is AWS manage node group. Okay, now let me dive in a bit, you know, what exactly how's your container run inside an EC2. So let me draw it out here inside an EC2. So at the bottom is the hardware managed by EC2 service. On top of that is the Linux kernel, right? And inside the Linux kernel, there are some very important components like C group, namespace, namespace, and others. I don't, draw everything. This is the Linux kernel. On top of Linux kernel is container runtime, container runtime, and on top of it is your port. I'm gonna, for example, your port 1 and the port 2. Okay, so there are some notes. The first one, those ports share, they shared CPU, memories, right, via the C group or the control group. So you set up CPU request limit, right? Request limit, and then C group will manage how to constrain, how to share resources between parts. So you set it. So this is your task. You manage those, right? You manage the via the YAML, and then C group control it. The second is you choose EC2 type, right? You choose EC2 type, and you optimize, how many ports are launched in these EC2s. So you manage, parts. I mean, you want, optimize how many parts on EC2s. I assume that you have only one part running on the EC2s, but you pay for the EC2, you pay for the entire EC2. So that's basic about node group. Now let me explain about the Fargate profile. So EKS Fargate profile. So assume you are an user developer here, same as before, and there is a control plane. So control plane. Also, it lives in AWS managed VPC, right? And in control plane there is API server. API server. But now it's not the default scheduler, but it is a Fargate scheduler. Fargate scheduler. And assume that you want to deploy some part, connect to the access endpoint, go to the API servers. I want some part I want some port via the kubectl command. Right, so what happened in case of Fargate profile? What happened? So what happened? Let me draw the data plane. So this data plane is not live in your account, not your VPC, but it live in AWS manage or Fargate VPC. Right? Different from the node group, it live in AWS Fargate VPC. This is the key point, right? And now you want some pods. Maybe you want 4 pods. So how the pods are launched in here, right? So there are some box. I call it a Fargate box, and another Fargate box. There are many Fargate box in here, right? The important thing is only one port per box. So the port 1 live here, and the port 2 live here. So only one port per box. Right. And now let me explain what is the Fargate box, what exactly it is. So let me draw it. So out here I'm gonna draw the box. At the bottom it is a hardware, but this is the bare metal server, and it managed by EC2. Right? It is kind of a big physical server, a big physical server. Right? A big physical servers like 1 terabyte RAM and many CPU cores. And on top of it is the operating system, Amazon Linux 2. Right? And on top of it is a Fargate agent. So it can talk to AWS Fargate service. And now the important part, the container runtime, is called containerd firecracker. So this is the container runtime. Important. And on top of it, another important component called firecracker virtual machine engine. And on top of it, via firecracker virtual machine engines, it can create many lightweight virtual machines. So let me draw the first lightweight virtual machine 1, and then another virtual machine 2, and then another virtual machine 3, and so on and so forth, right? And inside one virtual machine there is one port. So this is your port 1 live here, port 2 live in here, and port 3 live in here, and so on and so forth, right? So you see it had another layer of isolation called firecracker. Firecracker create multiple virtual machines. It's lightweight. So that is the most important point, right? And it create, one pod per box, and it create more isolation compared to containers, different from only container, right? And from Firecracker virtual machines to the OS, this part managed by Fargate, right? So you don't see EC2 instance, you don't see any EC2 servers, right? And you only pay when your pod running, your container running. So you pay for pod actually running, right? Let me show you the document. So basically it says that here, right? So each pod that runs on Fargate had its own isolation boundaries. So pods had its own boundaries and don't share underlying kernel. Because each pod, you see, each pod lives in a virtual machine. This is a key point, right? This is the key point. Got it? About the resources, you can config, for example. So you can check the document to see, right? So you can config smallest 0.25 virtual CPU up to 16 virtual CPUs, and it not share between pods. Okay, so I think you get the basic idea of Fargate profile. Now let me go to the CDK code and demo it. Now I'm gonna demo. So now I demo. So I already have an EKS cluster, and then I use CDK and I add Fargate profile, and then I launch pod onto these profiles, using some selector. Right, so pods can select Fargate. Okay, so let me open the code and show you. Okay, let me zoom it. So now how I assume that I already create a cluster, right? And let me show you from beginning. Zoom a bit. So I already create a cluster here, right? Now how I add Fargate profile, right? So let me uncomment. Okay, so I'm gonna uncomment and explain it. Okay, so there are some parameters you need to know. First, I create the Fargate profile, and I, for what cluster, right? So for this cluster name, and I need to assign a role for profile. So let me come back here. So let me draw. So this is a Fargate profile, right? And then I attack role for the Fargate profile. So each pod 1, pod 2 in this Fargate profile will have role and policy to access AWS service. For example, to send a message to CloudWatch, right? Okay, let me come back the code. So this is about the role, and then so I need to set up, I want some pods will be launched into this profile. How can I do that, right? So this pod or this Fargate profile is for specifically, allocated for a namespace in Kubernetes, right? And then I use labels. So later on, I will create some service. I will create some deployment with namespace demo and with label environment dev. So given namespace and these labels, it match with this Fargate profile. So my pods will be launched onto this Fargate profile. That's it about the label and namespace here. Okay, so that's the most basic thing. And now let me deploy it. Okay, so when I deploy, it will create the Fargate profile. So let's wait a bit. I think it's gonna ask me some confirmation. So while waiting, I can show you the deployment I want to launch into Fargate, right? So I make just a deployment with 2 replicas, and it run a simple image, and then I request 256 milli CPU. So this will go to the pod profile. In here, you see, sometimes it has to round up because of step size. You see, this is the step size. Okay, let's see. Okay, now I think it's deploying. Okay, so let's go to the cluster. Also CloudFormation cluster. Oh, sorry. Okay, looks good. Compute, right? So now it's creating the Fargate profile demo for me, right? Okay, so it's creating. I think it takes 1 or 2 minutes. It would take about 1 or 2 minutes to create the Fargate profile, so we're waiting a bit. 2 minutes. I got deploy done. And let's go here and check the, okay. So now the Fargate profile demo have been active. So, okay. So this namespace and mesh label gonna help us later on when you want to launch some pods onto the Fargate profile, So the namespace and the mesh label have it, right? I already explained. Now I go to cd YAML, and I will deploy this deployment, web app deployment, namespace demo, the label environment dev, and it should be launched onto the Fargate profile. So let's cube apply f hello Fargate, right? Okay, and let's check cube get pods namespace demo. Okay, so it's pending, and we can check also from here resources namespace demo. Okay, so this is 2 pods, and wait a bit. is not yet running. So for the Fargate profile, I notice is the take a bit longer than the node group. I think because that is the virtual machine, the firecracker engine. Okay, so eventually it launched into the Fargate box, right? This is a box I set. This is a box I set, and one box, only one part, right? So now I come back here, cube. Okay, now let me check cube get nodes. Okay, so this node is not actually an EC2 instance, but this is a Fargate box as I said, and it is a firecracker virtual machine. And let's see, cube describe node. So we jump in a node and see. Okay, so let me zoom in and running. Okay. Oh, so there's some information about the node, right? We request 256 milli CPUs. So the virtual machine for this part, have much more CPU, right? And we consume only 12%. So that changes, and what happened? So if I request more one CPU, right? So now I see cube get node, right? So we have a node 65, 20, and 36, right? And now I changed the number of CPU I want, and I think that it Fargate need to launch a different Fargate box for me. So let cube apply hello Fargate. I request much more, 10 times and 10 times, and in here, okay, so I request much more CPUs, right? And I think Fargate will launch different box, different Fargate node, Fargate box which much more bigger. So let's check cube get nodes namespace demo. Cube get pods namespace demo. Is that running now? It's still one is still pending. So let's wait and see. Let's go to the UI and see the compute, the demo, resources, namespace demo. Yeah, it's kind of a rolling update, right? It's kind of rolling updates. And let's see. And let me get the node also. I think it create a new node. Okay, I think this is a new node. Before we have 65, 20, 86, and now we got a new node. So let's see this one. Describe node. It should be bigger. Okay, yeah, you see. So CPU, right? This one is I request about 10 virtual CPUs, and this machine has about 20 virtual CPUs because 10 CPUs only 64%. So it already launched a new Fargate box. Cube get nodes. I think now it's all running. Okay, so it already finished the rolling update, and we have to pause runnings on two new, on new, much bigger Fargate nodes. So that's it, and thank you.